Thank you very much. My name is Thorsten. I'm a little bit nervous, so maybe all of us take a deep breath. Okay. Maybe this inside block can just move in 1 or 2 seats if there's people coming in. Oh, okay. Good. So hopefully we make this a bit lively and you get to learn something. I'm very glad to be here in Vietnam. I've been working with Vietnamese engineers for about 10 years already. Some of the best engineers I've worked with, so I'm very glad for all the talent that's developing. I'm going to tell you about some of the challenges about enterprise RAG, and enterprise LLM. Many of you, of course, following all the models, Llama, Mistral, all those developments, but when you take it into a business and you take it into enterprise, it's a different type of challenge. I work for Standard Chartered Bank in a department called SC Ventures. We do innovation, but all the views are personal. So the bank might develop strategies in their own way, but these are my learnings to you. The recap, what we want to do is really just look at recent developments, very short. We want to step through some conceptual architecture of how to run these things in production. This is a bit experimental, and then a demo. And please, you might want to pay attention and not use all the bandwidth, otherwise my demo will suffer. I'm just kidding, but please do pay attention. So we're talking about enterprise capabilities, and so we're seeing an emergence of course, of a lot of different models. You know, multimodal use cases. NLP has been around for a long time, but now also just the GPTs, the transformers. Computer vision, you know, in our bank, for instance, we process something like 40 million trade documents a year, right? These are like PDFs and faxes and all sorts of documents. We need to extract data out of the OCR. And audio is becoming popular, right? Voice generation, IVR systems. So we need an ability to manage all of this, and the organization needs to align around that, and that's not easy. And obviously, all have different skill sets, but if you put them into a picture, you probably fall into some of these different categories, and they have to work together, and they have to establish a process of taking the kind of concept of the model all the way through to production, and this is not always very easy. And you see there's a certain governance that's required too, in terms of what models you're developing, who's using them, when they get deployed, what versions, how to do the deployment themselves, and then very important also model serving. So all of you using chatgpt.com, openai.com is of course hosted externally. When you bring it into a business, you need some more robust infrastructure. What makes this all work is of course a lot of layers of technology. A caveat, the stuff is changing constantly. It makes it very difficult even as an engineer to keep up with all of that. Dependencies and all that, classes, projects changing, namespaces changing. But you know, in this case, I've taken a look at Ray, and Ray is an amazing runtime. It's also been used to train the OpenAI GPT-4 model and prior models. So it really serves as a complete suite, but you can run all sorts of tools on top of Ray. And so what I've kind of found in interacting with the corporate, with the bank, with my stakeholders, even with some of the ventures that we work with, we build startups within SC Ventures. So we have 25 startups who are adopting or looking at AI and ML, is this kind of need to have a segregation between what is your internal AI and ML. So traditionally, you would have always, a bank, for instance, would have always had AI. I don't know about the Vietnamese banks, but certainly the international banks have for a very long time. Now, of course, extending that to language models. We then have third-party models, which are your SaaS providers and your Hugging Faces and external. And then lastly is your emergence of vector stores. I think there was a question earlier around some vector databases. But maybe also importantly, if you haven't, or if this space interests you, is to take a look at graphs, right? So I don't know how familiar you might be, but graphs play an important role in retrieval simply because it helps you navigate how you get to the right kind of documents and how you shortlist the relevant information. Bit of a tricky space because both vector databases are emerging, and there is, of course, plugins like PG Vector, but you have other competitors like Pinecone, Weavient, Milvius, who are very strong vector databases. And you have graphs like Neo4j, strong graph database, but again, trying to bring the two together is still quite tricky at this time. Important is you kind of need three. You need all three of these capabilities. The reason is a lot of the data in large corporates, if it's a telco, if it's a, I don't know, a conglomerate or a bank, is sensitive. So you want to potentially put that through your internal models. When your staff is making content for the website or some sort of LinkedIn post, they probably want to use a very strong model and maybe something like GPT or externally hosted Claude. And lastly, the data, you need to store the data somewhere, but these databases here aren't necessarily your source of record, right? They're like a temporal store or maybe a transient store. They get their data in from PDFs, from Word documents, from websites, from any other external records, processed into a certain format, embedded, and then stored in your vector databases. And so it kind of brought us to think about, like, how would we do this if we have to serve a whole bank, right? We have 100,000 staff in the bank. It operates across 59 countries. In my smaller type ventures, we've got little businesses in different geographies. And so we thought, okay, we have to put these components together. Very often what you'll find is that you might be building a model and you use, I don't know, fast API and you got the thing up and running, but it's not enterprise grade. Next thing, you have a bigger kind of company, I don't know, Viatel or other telco or corporate. They've got departments. They need to keep track of who's doing what, who has access to what models, who's calling which APIs, how much do we bill them. So you have all sorts of complexities in how you run internally. The other, of course, is that you need to build something scalable to serve these models, because as your consumption grows, you'll need GPUs, you'll need some sort of infrastructure in the back end that also allows these models to perform. And I was having a chat yesterday with Theo about Macari, and again, you know, the big topic there, which maybe doesn't get enough attention, but is really performance, right? Into milliseconds and very high performant serving. So what we got here is a kind of a conceptual, you know, approach where we're saying, let the developers continue to use LangChain or Llama Index, because those are the tools that they're familiar with, but make it possible for them to go and access these models through a managed infrastructure, right? Again, you'd appreciate if you're young and you're working kind of on your desktop, it's easy to make a call onto the internet. If you're in a corporate environment or a larger network, you probably have some gateways, you maybe have Zscaler or some other network edge protection devices. And so you probably want to take that through a kind of central infra. But at the same time, you need to support the deployment of new models coming in. And that needs to be done in a very regularized manner, because otherwise everybody's just going to throw you their piece of source code or their piece of Python code and expect you to run that centrally, and that's going to break very quickly. Talking about some of these, and I'll give you a quick demo, about 5 minutes of kind of deep dive. This is fairly new. There's some components which are emerging. This is a light LLM, and it's not an LLM. Sorry, it's it's kind of an LLM gateway. What's interesting is that it's emerging very much into the space where you know, I guess everybody's needs are, but it's not big enough to really make it commercial. It is open source. Luckily, it's got some great features, and I'll show you what it does. But principally, you're now in a position to start managing who has access to what, how much they've consumed, how many tokens, what is the cost. You can set budgets, you can set thresholds. We can do content inspection before we take the data onto the public LLM. So quite a lot of actually very neat features. Separately, I'll just talk about Bento ML. It's a very cool kind of open source initiative to wrap models into containers, align them to an international standard so that you can deploy them across different platforms. And it's all command line based, right? So you can very easily take kind of a model that you've written either, you know, using your own, let's say, classifier, or even language models, and package them. So if I drill down into that, it supports a very wide range of models. And so the native ability here is just to draw on what is on Hugging Faces or Microsoft or other model sources, bring them in, build them, make sure the thing works. Of course, you can run them, which we'll demo in a moment, but then also deploy them through a kind of managed pipeline into a production environment. And that brings me on to Ray. And so Ray is a model serving platform, and there are, I think, just a handful of them. You know, again, you need something that can do this at scale and then manage the clusters, manage the resources, manage the scheduling. And so Ray Serve more specifically does this, is one of its components. And the nice thing here is it doesn't really care about what type of model you're running. It kind of gives you the observability and the mechanics to look into what's actually happening behind the scenes. It's not down to the data level, so it doesn't perform an auditing or logging function, but it really just looks at the overall operations of your kind of model serving infrastructure. So again, if you think of a business, anybody who's building systems around that, what you can now do is effectively create a centralized function that does model serving to the entire organization, right? You don't have to put models into every single business application and deploy them locally, and you have GPUs, other resources distributed across the org. You kind of end up with something that is centralized and can provide that probably in a better, more scalable manner than if it is federated and distributed. Okay, who wants to see a demo? Okay, only these guys. The rest, okay, I'll let you stay. But this might break. Let's see how this goes. Okay, hello. Okay, so let's have a look. I've scripted this to make sure that we don't fall over. But I like demos because it makes it a bit more real. So first of all, Bento ML, just a kind of front end in allowing me to interact with my containers. What I can do is I can do my models list. And so I can manage effectively all the models that I've compiled here, and I've pulled them in. So what you can see is I've got some underlying machine learning models or other, for instance, in this case, transformers that I've pulled in. And I've already put these together and compiled them. And so what I can do is I can now say I want to run this model. Let's say in this case a classifier. And what will happen is Bento ML will take that Python code. Maybe I should have showed you guys what it looks like. Maybe I'll do that afterwards. And actually brings it up and serves it to me. So in this case, I did not have to go and write in any HTTP handlers, any like fast API or any front end. It just, Bento kind of wraps that straight off the bit of Python code and gives me that front end. So if I show you here what that looks like, we can go, sorry, that's this one. Let me take that one. So what we've got here is the classifier is now running. It's running on a port 3000, and we can go to the different perhaps methods that exist in here. But you can see it's added in other methods around health checks and so on. So the nice thing about Bento is it simply takes care of all of that. I can start serving the model and consuming it as an API. If I put in some data here and I execute that, just to make sure I'm not cheating anybody, the result is 0. And if I put it through my classifier model, okay, the result is 2. I didn't hard code that value, just to be clear. So we now have a response from the Bento model, and we can see the requests being served in the background, right? Now, what I can do now that I've built this, I can simply take that same model. So I shut this down, and let me just see where I go. Oops, okay, that's probably not correct. And I can serve this. So if you look at kind of how I package that for Ray, what I've simply done is I've said, well, there's a Bento model, it's containerized, it's built already, and now I'm going to run it and deploy it onto a Ray cluster. The Ray cluster can already be running, right? So if you've got a big cluster, 20 machines, GPUs, all that, I can simply take my piece of code and push my model and say, run it on that destination. And it's actually pretty straightforward because I just run this nice command, serve it, and fingers crossed, it'll power up my, my Ray cluster and deploy the Bento container with the model inside. Okay, so what does that look like? Hopefully this loads. Check. So again, think of internal infrastructure within a corporate, right? Now I've got my Bento running here. I can see the job. I can see certain information around within it. And as I said, it's got all sorts of logging and details here. So if we wanted to see the requests come through, I can probably just go into my Bento as it is running here. And you see that log is empty. But nonetheless, I didn't have to worry about anything other than run a few commands, and my machine learning model is now in production and exposed. So again, now you can see that the port is actually changed to 8000. Maybe also important to note is the container is not running, so that Bento is not running as a container, but it is within my Docker, right? So my classifier is here, but it's not running within Docker. It's actually running within Ray and being served. So if I go to my prediction service, oops, that was it. So you can see if I go to that and access it through Ray now, I'll get the same endpoint. But again, just to make sure it actually works, I can put some data through that model and I get a response. But I can now also see that the requests are coming into my Ray. So that takes care of the foundations. Now, taking that forward, and oops, being a bit too fast here, I'll bring in the proxy. So what I'm going to show you now is this light LLM. I've just configured it. Kind of nice, because in here, you might not want to take screenshots of my access keys, but nonetheless, it's kind of a configuration in YAML that allows me then to hide all the keys that my enterprise uses, right? So my enterprise has one subscription to OpenAI, one subscription to Hugging Faces. I don't want to give those keys to everybody in the bank, right? I'm going to have a big problem, and then next I'll have like 5,000 consumers accessing this from home. Instead, I put the keys into the YAML, I run it in the backend, and now it's connected. And let me just see, how do I access this? So now I've got my light LLM up and running, which is the front end. So think of like an Nginx to some extent. Oops. Yep, that can happen. I know why. Localhost. Think of like an Nginx or like a reverse proxy, HA proxy, but more intelligent. And it's got a whole bunch of APIs, which I'm not going to bore you with. But if I go here to the admin panel, admin top secret, okay. We can now see effectively what's happening within my managed API gateway, right? So here, for instance, different entitlement. If I don't want Thorsten to have access to a certain model, I can remove it or add it. So there's different capabilities for managing models. I can test the API if I want to, set up different teams, but more importantly, I can look at usage, and I can now take that usage over a period of time and send that finance department like a $1,000 bill, and I can have that per day and whatnot. Sorry, I just touched this the first time a few days ago, so it seems to work. I'm quite glad. Okay, and so we can see where the consumption is coming from, and it does all sorts of verification. So if we look at perhaps what a request might look like, if I take it through my proxy, if you guys are familiar with Python, it's Python. I love-hate relationship. Okay, so here's a piece of code just to make a call. But as you can see, I'm not pointing it to OpenAI. I'm pointing it into my local host where I'm running the proxy. And then obviously I just wanted to write a short hyco. So if I run this, this is called proxy request. Oops, I'm in the wrong path. Let me just do like that. Okay, it'll now proxy that. You'll see the request go out, and we got a nice poem. Code flows freely, the open source river, knowledge share with all. Beautiful. And you can see the requests go through the proxy here. So what that means is I can also do things like this, which is important, because now if I'm a company and I don't want people abusing my prompt, if somebody takes a message in like ignore previous instruction, it'll actually get filtered out before it even gets to any of the models behind the scenes. So getting to the punchline, we've also talked about embeddings, right? We briefly talked about embeddings earlier, I think. Embeddings is obviously turning a string into vectors, right? So this is what it looks like. It looks a bit confusing because this is now put through a model, and the model has mapped these values, and it's really just a few string, this short string here, into these floats. And in order to make use of that now, I can see, I need to just change my dependency, otherwise it will not work. And I'll show you a quick demo of, for instance, me now inserting a kind of database of, in this case, wine. I think, oh no, what happened there? Is that, I'm in the wrong folder, hold on. That's the trick. Okay, so I'm going to import a database of wines into a vector database. What's actually happening is it is taking this text, it has put it through an embedding model, and it has then inserted it into a Weavient container. I'm a big fan of Weavient. If you haven't checked it out, you should. And in this case, it's actually taken the embedding instructions through my light LLM gateway. So again, what I've done is I've been able to create a vector database, stores all my data, but in order to do the embeddings, it'll talk to my local LLM gateway, and then it'll go out into the models, and those models can be served either publicly, like OpenAI, or those can be served internally. So why is this important? Why is this fun? Because now we can look at that embedded data. So you saw that it was kind of processed through my my vectors, and I can now go to my Weavian front end. It's actually a very cool front end. I'm going to try something just to show you what it looks like. Weavian dashboard. Let me just go here. Okay. So what you can do is you can literally use this web-hosted front end to connect to your local host. So this is a container running locally. And what I've got here is I've got a GraphQL query directly onto my vector database, right? So the nice thing is I can, for instance, say, pull me out all reviews out of the vector database, and there we go. Or if I'm going to do a search now using, for instance, I would like to find some wines that taste like green fruit. I am now retrieving those out of the vector database. But again, to make clear, right, just to show you what that looks like, is that these results are being retrieved through my embeddings API, which is running within my own environment. So back to that demonstration, is in that quick rundown and going through these different type of technologies, we kind of had that set up. We had the vector database interface with the AI gateway. That arrow is not on the diagram. We had the models and like the classifier being hosted internally on Ray. And we also had calls out in public cloud. And so I hopefully, I kind of hopefully want to leave you with this kind of curiosity around what this looks like at enterprise scale, if this is something that you can use in your own environments, and of course to think about all these non-model related concepts around things like billing, observability, role-based access control, token consumption tracking, vector databases, because all of these things are critically important. And unless you, especially maybe a younger audience, doesn't spend time on this, you're gonna struggle putting systems into production, because doing things client-side is easy, doing things at enterprise scale is quite difficult. Thank you.